Everyone, welcome back to my channel. So in this video we'll start solving the past question of math 122, that's calculus 1. So we just start with the first question. Suppose that limit as x approaches 0 of f of x exists. So we are supposing that it exists, and this x square plus 25 minus 5 all over x square is less than or equal to f of x all over x plus 10, which is also less than or equal to 2x minus x squared all over 20 e to the power x, so 20x, so 20x e to the power x. Find the limit of f of x. So we are finding what? We are finding f of the limit as x approaches 0 of f of x. So let's dive into the solution. So let me open my notebook here and let me just write the question afresh. So root of x squared plus 25 minus 5 all over x squared less than or equal to f of x over x plus 10, which is also less than or equal to 2x minus x squared all over 20x e to the power x. So let me cancel this. So we are find limit as x approaches 0 of what? F of x. So first let's rationalize this guy. Let's rationalize the numerator. So if we are rationalizing the numerator, we multiply it by what is conjugate. So the conjugate of the numerator, so root of x squared plus 25 minus 5 all over x squared times root of x squared plus 25 plus 5 all over root of x squared plus 25 plus 5. So we multiply both the numerator and the denominator by what? The conjugate of what? The numerator, since we are rationalizing the numerator. So this will be less than or equal to f of x all over what? X plus 10, which is less than or equal to, so let's factorize. X is common throughout, so let's factorize the x out. So I have x bracket 2 minus x all over x bracket open 20 e to the power x, 20 to the power x. Okay, so we close our bracket. Let me just minus all that. Okay, so this will give us this times this, this is just difference of our two squares. This and that are just difference of two squares. If this is our a minus the 5 is our b, then it's just multiplying what? It's multiplying our a plus our b. So it's just difference of two squares. So you can just say that this is the same as root of x squared plus 25 all square minus 5 square all over x square multiplying the square root of x square. So bracket, let me just put bracket open, x square plus 25 plus 5. This is less than or equal to f of x over what? X plus 10. So here x is common, we cancel it out. Less than or equal to, so since we've cancelled out the x's, we now have 2 minus x all over 20e to the what? X power. So with this, we continue from here. We have the square cancelling the root, leaving x square plus 25 minus 5 square is 25. So we just have x square all over. So that x square to, okay, let me just leave it at, let's just continue. X square bracket open root of x square plus 25 minus, sorry, plus our 5 is less than or equal to f of x over x plus 10, which is less than or equal to 2 minus x over 20 e to the x. So now let's isolate the f of x. Let's make it stand alone without the x plus 10. So we multiply through by the x plus 10. So here x square will cancel x square. So if we multiply through by x plus 10, we have x plus 10 over square root of x square plus 25 plus 5 is less than or equal to f of x, which is less than or equal to 2 minus x over 20. So 2 minus x to multiply x plus 10 over what? Over 20 e to the x power. So now let's take limit as x approaches 0 throughout. Let's round this throughout. So everything we will take limit as what? So throughout, as we will take limit as x approaches 0 throughout. So we now have limit as x approaches 0 of x plus 10 over square root of x square plus 25 plus 5 less than or equal to limit as x approaches 0 of f of x less than or equal to limit as x approaches 0 of x minus 2. So x minus 2 x plus 10 all over 20 e to the power x. So now let's perform the operation. So here wherever we see x, we put 0. So we now we'll have 0 plus 10 over square root of 0 square plus 25 plus 5 less than or equal to limit as x approaches 0 of f of x less than or equal to, wherever we see x, we put 0. So 0 minus 2 multiplying 0 plus 10. So 0 plus 10 all over 20 e to the power 0. So let's continue. This will give us 10. 0 plus 10 is 10 over 0 square is 0 plus 25 is 25. Square root of 25 is 5. So 5 plus 5 is what? Is also 10. Less than or equal to limit as x approaches 0 of f of x less than or equal to so now check something. Since I left out something, check here. So it was 2 minus x, but here we flipped it, so it's 2 minus x, so this becomes 2 minus 0. Okay, so that's what I just wanted to correct. So now that all the mistakes we made initially, we just changed. Instead of 2 minus x, we started writing x minus 2. So since we've corrected them, we can now continue with the solution. So 2 minus 0, so now that our x is 0, so we have 2 minus 0 is 2 times 10 is 20, so we have our 20 all over 20 multiplying e to the power 0 is 1, so all over 20 so we have 20 over 20. So now we have 10 over 10. 10 over 10, we know 10 over 10 is 1, so 1 less than or equal to limit as x approaches 0 of f of x is less than or equal to 1. And by the squeeze theorem, so by the squeeze theorem, we conclude that the limit as x approaches 0 of f of x is equal to 1. So if 1 is less than or equal to the limit of this, which is also less than or equal to this, then that means that the limit as x approaches 0 of f of x cannot be anything other than 1. So since it is bounded between the ones, so we have the value for it. So now we are done with the A part of the question. So let's see what the next question wants us to do. So the next question asks us to evaluate the integral this. So we are evaluating 0 to k 8x minus 12 over x plus 1 multiplying 2x squared plus 3 dx. So we are evaluating this, and hence we are showing that, so if we call this, let's say f of x, we are showing that the integral of f of x is equal to what? It's equal to ln, so the logarithm function, the natural log function, so ln 419. So let's quickly go through that one too. Okay, so let me have this question here, how it is. So since 0 to k, we have 0 to k 8x minus 12 over x plus 1 2x squared plus 3 dx. Since we have this will be very it will be very difficult to integrate. This is very difficult to integrate, so let's say that let this 8x minus 12, let's change it to partial fractions. So maybe if they are in partial fractions form, we can easily integrate it. So let 8x minus 12 all over x plus 1 2x squared plus 3 equal to a over x plus 1, so we are writing this as a partial fraction, plus bx plus c over what 2x squared plus 3. So this means that our 8x minus 12 will be equal to a multiplying 2x squared plus 3 plus bx plus c multiplying x plus 1. So at x equal to, let's say at x is equal to -1, we have -20, so -1 times 8 is -8 minus 12. -20 will be equal to so here -1 square is +1, 2 times 1 is 2 times 3, so I have, so 2 plus 3 is 5, 5a, and this, the entire this will become 0 because -1 plus 1 is 0, so 0 times anything is 0. So we have this, so which means that our a will be equal to our -4. So also at x is equal to 0, we have -12 equal to, so here we just have 3a, so our b will become 0 plus c. So we know a, but a equal to -4, so this means that -12 is equal to -12 plus c, which means that our c is equal to 0. So finally at x is equal to 1, we have 8, so this will become 8 minus 12, which is what, -4, will be equal to, so 2 times 1 is 2, 2 plus 3 is 5, so 5a plus, here this becomes b plus c, and this becomes 1 plus 1, which is 2, 1 plus 1, which is 2, so 2b plus 2c, but our c is 0 and our a is -4, so we can have -4 minus 5a. If we bring, okay, it's equal to 5a, so 5 times -4, let me just write the answer positive. 5 times -4 is -20 plus 2b, so this becomes 0. So this means that our 2b is equal to what, 16, which means that our b is equal to 8. So now remember that, let me send you to what we said initially. Remember that whatever we have in the integral part is now represented by these partial fractions. So but 8x minus 12 all over x plus 1 2x squared plus 3 is now equal to a over x plus 1 plus bx plus c all over 2x squared plus 3, which means that this guy 8x minus 12 all over x plus 1, 2x squared plus 3 is now equal to, our a is negative 4 over x plus 1 plus our b is what, 8, so we have 8x, our c is 0, so plus 0 over what, 2x squared plus 3. So now we now have the integral of from 0 to k. So instead of writing this, we now have what, negative 4 over what, x plus 1 plus 8x over 2x squared plus 3 dx, and this is equal to, so remember we reduce this is equal to 0. From 0 to k we have the integral from 0 to k, negative 4 over x plus 1 dx plus integral from 0 to k integral from 0 to k 8x over what, 2x squared plus 3. So let u is equal to what, x plus 1 and v equal to 2x squared plus 3. This means that, so we are doing substitution here, this means our du dx will be equal to 1, which implies our du is equal to dx, and dv dx will also be equal to what, 4x. This means that our dx will be equal to dv over 4, or you can 4x, or you can say 1 over 4x dv. Okay, so by substituting u for x plus 1, we now have negative 4 over what, so from 0 to k, negative 4 over u du plus the integral from 0 to k, from 0 to k 8x over, in place of 2x squared plus 3 I have v, multiplying dv over what, 4x. So here this will cancel this will cancel this too. So now let me take the constants out of the distance, the integral. So now I have negative 4 integral of 0 from 0 to k 1 over u du plus we have 2 integral from 0 to k 1 over v dv, and this equal to, so note that the integral of 1 over u, the integral of 1 over u is equal to ln of u plus some constant c. So for here we won't bring any constant here, we'll just bring a general constant for the two terms. So we have this as minus 4 ln of u plus 2. So similarly, the integral of 1 over v, and also I've forgotten about the k, so let me not forget about the k. So we have from 0 to k, plus the integral of, so 2, the integral of 1 over v is also ln of v. So usually you can put it in the magnitude bars to indicate that it's positive, but in the question they've indicated that k is greater than 0 or k is greater than 1. So okay, but let me just bring it. So we have this, so plus some constant, let's say capital C. So now we'll have negative 4 ln, in place of our u, we now have our s plus 1 back, 0 to k, plus 2 ln, in place of our v, we now have our 2x squared plus 3 back, and this is 0 to k. So let's continue to evaluate this. We have minus 4. So first we substitute what? K for x plus 1 minus so let me have it this. So let me factor out the negative 4. So minus the ln of 0 plus 1. So this will just 0 plus 1 plus 2 bracket open ln of 2k squared. So we substitute k for x plus 3 minus ln of, so ln of 2 multiplying 0, so 2 multiplying 0 square plus what? 3. This will lead us to so because of the spacing, and see whether I can thicken this. Okay, it will be fine. So this thing, I can't even see this thing. Okay, so I think this is fine, but it doesn't include all. I hope you can still see. So I have negative 4 ln of k plus 1, no minus this thing, ln of 0 plus 1 is ln 1, and ln of 1 is 0. The ln is also same as a logarithm of the base e. So you know logarithm of 1 is 0. So it's a rule, and we don't have to waste our time there again. So we have plus 2 multiplying ln of 2k squared plus 3 minus ln of 2 times 0 is 0 plus 3, so ln of 3. So now we can now bring it out from the bracket. So let me arrange it. Okay, let me have it this negative 4 ln of k plus 1 with that way plus 2 ln of 2k squared plus 3 minus 2 ln of what? 3. Okay, so let me arrange it this way. We have ln of 2 ln of 2k squared plus 3. I want to have my positive first, minus 4 ln of k plus 1 minus 2 ln of 3. So now we can have it as ln of 2k square plus 3 all square minus, so let me just have it this way, ln of x plus, sorry, k plus 1 all to the power 4 plus ln of 3 square, which is, let me just write 9. So if we apply the properties of logarithm, we have ln of 2k square plus 3 all on 9 minus, so this they are added, so we can just have it as ln of, since we have addition between logarithms, we multiply the terms, 9 bracket k plus 1 all to the power 4, and here this division is subtracting, so since they are subtracting, we can do what, we can divide. So this is equal to ln of so 2k square plus 3 all square all over 9 multiplying k plus 1 all to the power 4. So this is equal to ln of, so this we can simplify this to 4k to the power 4 plus 2 times 2 is 4, 2 times 2 is 4, 4 times 3 is 12 k square plus 3 square is 9 all over 9 multiplying, we can use we can simplify this one too, so you know 3 is 1, 3, 3, 1 Pascal triangle, so 4 will be 1, 4, 1, 4, 6, 4, 1, so we apply it here, so k square plus 4 k cubed plus 6 k square plus 4 k plus 1. So we are trying to prove, so we are done evaluating, but now we are trying to prove that the integral from 0 to k of, let's say, f of x, let me just put the actual value there, 8x minus 12 all over x plus 1 to x squared plus 3, x is equal to ln of 4 over 9. That's what we are now trying to prove. So we are done evaluating, and now we are proven, because it is hence, after evaluating, they say hence you should do what, you should show that this is equal to this. So that's what we are trying to show. So this is equal to ln of, so 4k to the power 4 plus 12k plus, so this to the power 4, right? 12k square plus 9 all over 9k to the power 4 plus 36k to the power 3 plus 54k to the power 2 plus 36k plus 9, and this equal to ln of, so we can factor out the k to the power of 4, even 4 plus what, 12k, sorry, 4 plus 12 over k square plus 9 over k to the power 4 all over k to the power 4 out, 9 plus 36 over k plus 54 over k square plus 36 over k cube plus 9 over k to the power 4. But from the question, let's visit the question once again. So from the question, we have that where k is a positive real number with k greater than 1. So since k is greater than 1, k can be any number. It can be even approaching infinity. So let's take k as it approaches infinity, because k is greater than 1. If it was less than 1, maybe it will be approaching negative infinity. So k can be approaching negative infinity. So in this case, k is approaching positive infinity. So let's have it that, and let's solve it. Okay, so limit as k approaches infinity of the logarithm function of, so these guys will just cancel out, leaving 4 plus 12 over k square plus 9 over k to the power 4 all over 9 plus 36 over k plus 54 over k square plus 36 over k to the power 3 plus plus 9 over k to the power 4. So this is the same as, if we apply the laws of limits, is the same as the ln function of limit as k approaches infinity of 4 plus 12 over k square plus 9 over k to the power 4 all over 9 plus 36 over k plus 54 over k square plus 36 over k cube plus plus 9 over k to the power 4. So this is equal to, so if we apply the laws of limits, since k is approaching infinity, all fractional values of k will run to 0. So this will be approaching 0, this will be approaching 0. So we now have 4 plus 0 plus 0 all over 9 plus 0 plus 0 plus 0 plus 0. Okay, so we are getting there. So final we have limit as 4 plus 0 0, so it's just 4 over 9, and we have shown that this is actually true. So that is it for the first question. It's long and it's not easy, so please you just have to take your time and go through it. The questions, that was how that was how the questions were, and we managed to write the paper. So this is the end of the first of our first lesson, or of our first solution to Math 1 to questions. That's calculus 1 questions, and the questions are under what? Limits and integration. So that's what we've done, and in the next video we'll look at solution to question 2. So thank you very much for your time. I know that this is long, and maybe it might, I don't think it's boring, but if you feel so, please kindly let me know, and I really appreciate your time, and we'll see you in the next video. Thank you very much once again.